Recognizing special types of trinomials is going to make factorising much, much simpler for you. So some of the things that we looked at when we were expanding were perfect squares. So if you expand x plus b or x minus b all squared, then you end up with a squared plus or minus 2ab plus b squared. And knowing that can save you a lot of time. You can go straight to the factorised answer without having to do the cross method or the product, sum and factor method. So when you're given a trinomial, there's a few things you want to look for. The first one would always be common factors, but if there aren't any of those, then start having a look and see, well, does this trinomial fit a perfect square? So is my first term and last term square numbers? So let's have a look. M squared plus 14m plus 49. Well, m squared is obviously m squared. 49 is 7 squared. So then let's have a look. 7 times m, and then double it would be 14m, and that's exactly what we've got here. So instantly we know this is a perfect square that I can factorise to m plus 7 all squared. And it works even if the leading coefficient isn't 1. So 9a squared is actually 3a all squared. 4, now be careful here, our middle term is a negative. Because our middle term is negative, but our last term is positive, what that means is that we have two negative terms. Well, what negative number squared gives me 4? Well, that would be negative 2. Then check your middle term. So if you multiply the first and the last, 3a times negative 2, you get negative 6a. Double it, negative 12a, which is what we've got here. So therefore, this factorises to 3a minus 2 all squared. Now the ones that can be really tricky are ones like this. This is a fraction, and we don't tend to think of fractions as square numbers, but if you have a look at the numbers 9 and 16, they're both square numbers. So 9 over 16 is actually 3/4 all squared. So then let's check. What if we multiply our x and our 3/4? Well, we would get 3x over 4. But then if I double it, that will simplify to 3x over 2, which is what we're looking for here. So this is also a perfect square where our factors are x and 3/4. So then we also have the difference of two squares. So we're not dealing with the trinomial, we've only got two terms. But if both of those terms are square numbers, then it's very easy to factorise. So if you have something like 25x squared minus 9, you simply say, well, 25x squared is 5x all squared, and 9 is 3 all squared. And so when I factorise this, I get 5x plus 3, 5x minus 3. 16m squared minus 81 is again both square numbers. We have 4m all squared, and we have 9 squared. And so therefore we go straight to the factorised form, 4m plus 9, 4m minus 9. Now when asked to factorise and we get something like this, x plus 2 all squared minus y plus 3 all squared, it's often a student's first instinct to start expanding the brackets. They want to try and expand and simplify and make everything easier. But look really carefully at the two terms. You've got x plus 2 and you've got y plus 3. If you then start expanding, you're not going to be able to collect any like terms. You're just going to get a much longer, more complicated expression that isn't going to go very far. But what you do have here is the difference, because we've got a minus, of two square numbers. So we're going to factorise this the same way that we did above, but thinking that in this case our terms are x plus 2 and y plus 3. So what this factorises to is x plus 2 plus y plus 3 and x plus 2 minus y plus 3. So simplify that and I'll see you in class.